Hi everyone, welcome back to my channel. So today we are going to start a new series on one of the most important topic of mathematics, which is function. So in today's part one, when we're done by today's video, we are going to learn how a function works, what a function really is, and the domain of a function and a range of a function. And it's going to be a long series. We are going to have 6-7 videos in there, but by the end of 6-7 videos you'll be very clear about function, and I'm 100% sure that you'll be able to answer all the questions by yourself in IGCSE or IL. So let's start today's video. So first of all, let's understand what a function is and how it works. But before that, let's talk about a machine. Now we have a machine. So if we put flour inside that machine, what we get as an output is bread. Now the bread comes in a very specific shape, which is triangle shape. So again, what the machine is doing, we are putting something inside the machine. That means we are putting flour, and the machine is giving us an output, which is a bread in triangle shape. Now let's say we have another machine. The machine deals with number. It can calculate number, but in a specific way. Let's say the machine, if we put something, let's say if we put 3, what the machine does, we have a machine. What the machine does, it doubles the number and adds 3 with it. So doubles the number. I mean, 3 is going to be 6. That means 2 multiplied by 3 for doubling. And then the machine is going to add 3 with it. We are going to get an output out of this one. So 3 to the 6 and 3 is 9. So we are getting 9. So whenever you put 3 inside that machine, it's giving you an output 9. For giving you a result, it's working in a very specific way. What it is doing is doubling the number and giving us an output. Let's say we put another number. Let's say we put -2. So what the machine is doing, when it's going through the machine, 2 is being multiplied with -2, and then we are getting 3. So this is the process happening inside the machine. So what the machine is doing, 2 multiplied by -2 is -4 and +3. So ultimately you will see a result -1. So that's how this machine is working. Now let's say instead of numbers you put a variable. Let's say you put x. Again, the machine is going to work in that specific way. So it's going to multiply x as 2x and then +3. Obviously there is no value for x. We don't know what it is. You can put anything. So you are not getting any specific result from this one. The output will be as 2x +3. So look at these things. What the machine is doing is converting numbers in specific ways and giving us values. These machines that deals with number, variables, etc. in a specific way like this, they are called a function in mathematics. For this one, the output is coming as 2x +3. So in place of x, if we put anything, it's going to give us an output like this one. For this one, x is 3. For this one, x is -2. And this one, for x, the output is 2x +3. So for a function, we use the word letter f. And what's function is that, what's the input we are talking about? X. So we will call it function of x. So this is how a function looks like a function of x. And how does the function work? With the specific way, the specific ways is going to multiply the number with 2 and then adding 3. So we can say that this function works as 2x +3. So whatever you put for x, you are going to get a value like this, like 3 and -2, just put it. So this is how a function works, and this is what a function basically is. A function converts anything given to it in a specific way and gives us an output. Now let's see some more functions and how they might work. Now we have a function on the board. We have, first of all, we have the function of x, which is x divided by 2. That means anything I put in this function is going to divide it by 2. Let's see some examples. Let's say for the first function, if I put f of 4, what the function is going to do is divide that number by 2 and give me an output at 2. Now let's say if I put f of 5, what the function is doing is dividing that number, my input, by 2 and giving me a result. Let's say I put f of -16. So that will be the input. So the function divides it by 2 and gives me a result of -8. So this is how the first function works. Now let's see how the second function will work. So the second function 2, we are simply denoting this function as z. So z of x, what the z of x is doing, whatever I put in there is squaring that number. Whatever I am putting here is squaring the number. Let's say I am putting g of 3. So this function will square 3 and give me an output as 9. If this is, let's say we have 10, g of 10 is going to simply square 10 and give us output of 100. This is how the second function works, and this is how we can just put values and find different numbers. In your question, in your exam, the question could be, if the function is given, find g of 5. You just put the value in there and the function will calculate it for you, right? Okay, now let's see what our function 3 does. So function 3, we have denoted the function as h. So h of x, what it does, it is it square roots any number I put in there. That means if I put, let's say 64 in there, h of 64, what the function is doing is square root the number. So we are going to get 8 as an output. Square root of 64 is 8. If you put, let's say 121, so it's going to be root over 121, and we are going to get a value of 11. Now you can also put other numbers, not squared numbers, and you're going to get decimal. You can use a calculator and easily find the value. So this is how the third function is working. Now let's go to number 4. Function number 4, we are denoting this function as p of x, and what the p of x is doing is doing multiple things. First of all, it's adding 3 with our input. This function will add 3 with the input, then it's going to square that input, and then lastly it's going to do 2 plus add 2. So finally it's going to give me an answer. Now let's see how it works. Let's say I'm putting 2 in that function. So what the function is going to do is add 3 with 2, then square it, and then add 2 with the result. So first of all, 2 plus 3 is 5, square, then add 2, and then you are getting 25 plus 2. So you will get the output as 27. So this is how the function is working. Now you can put another number and it's going to work in the same way, because a function works in a specific way. So again, this function is adding 3, then squaring it, then adding 2, then giving you the result. So whatever the function is given, you can just put values and get answers from it or get outputs from it. So this is how a function works. We have seen some examples, and when you do the question paper video, we'll have more exam specific questions and examples. Now let's understand what domain and range of a function actually is. Let's go. So let's understand what domain of a function is first. So we have 3 functions in there. Now we're going to put numbers in there to get results, means outputs. So what can I put here to get answers? I can put any values. I can put a positive number, any positive number. Let's say I'm going to put 3. So what is the way of functioning of this function is going to add whatever I put with 2 and give me an output. So 3 plus 2 is going to give me a result of 5, right? Now let's put f equals a negative number. Let's say I'm going to put minus 3. Let's say we could put minus 3. Now this function works as it's going to add 2. So minus 3 plus 2 is going to give us minus 1. Now let's put 0. What are you getting here? We have 0 plus 2, so the result will be 2. So in all these cases, if we put a positive, we get a value. If we put a negative, we get a value. If we put 0, we still get a value. So the inputs here, you see 3, minus 3 and 0, they are called the domain of this function. That means whatever we can put logically into the machine to get a value is our domain. Whatever is logical to put inside the machine is the domain. For the example, in the previous example, in our machine we put flower. So flower is the domain of that machine or domain of that function. Here we can put positive, negative, 0, any number. Whatever number you put, you are never going to get an illogical value. Every value will be logical for whatever value you put. So every number we know is the domain of this function, because we can put any number here and we are going to get an output. So for this function we write, give a moment. So for this function we write the domain is all real numbers. That means any number we can put is the domain. So for example, domain is written as d, and whatever function we are donating with that function with, so it's as d of f. So that's how we write the domain of function. If it was g, we could have write domain of g. Okay, so d of f equals to any number starting from negative infinity to positive infinity. That means we can put all the numbers logically here and we are going to get logical values. This one can also be written as real number symbol of this one. That means we can put any real number in there. Okay, now let's move on to our function number 2, and let's say Let's see actually what happens here. Again, what can you put here? Can you put a negative number in there? You can. Let's say you put -5, and it's going to square the -5. Okay, so what's going to be is 25. We know that square removes any negatives. So if I put 0, I'm still getting an output 0 square. It gives us 0. Then if I put a positive number, obviously I'm going to get a result, right? 2 square. So it's 4. So as we are saying here, again, just like the previous function, whatever I put there, I can get a logical answer. So I can basically put anything in this function. That means anything is logical. So any number, just like the previous one, is a logical number as the input of this function. So our domain of f for this function is also real numbers, or the numbers starting from -infinity to +infinity. Again, domain is what you can put logically in a function to get a logical answer. Now let's move on to our function 3. So we have a function of x equals to 2 divided by x minus 2. Now what can I put here? I can put a logical number, right? Let's say I can put f of 3. If I put f of 3, I get 2 divided by 3 minus 2. So what do I have? The result will be 2, right? Now let's put a negative number. Let's put f equals -4. So if I put -4, I get -4 minus 2, which gives us 2 divided by -6, and we can simplify it to get 1 divided by -3, right? Okay, let's put 0. If we put 0, f of 0, we're still getting a result. So 2 divided by 0 minus 2, that gives us 2 divided by -2, which is basically -1. So we can't put anything logically, right? No, we cannot. There is a number we cannot put, and that is, for this one, is 2. What happens if I put 2? If I put 2, then it becomes 2 minus 2, which gives us 2 divided by 0, which does not logically give us any output, because we cannot divide any number by 0. That is undefined. So we cannot put 2 in this function. If we put 2 in this machine, the machine is going to be broken. Basically, we don't get anything. So 2 cannot be a domain of this function. We can put any real number in there. We are going to get all the possible outputs, all the logical outputs, but not 2. If we put 2, the denominator becomes 0, and any number divided by 0 is undefined. So we cannot put 2 as the input of this function. So 2 is not part of the domain. In this case, we write domain of f equals to all real numbers except 2. This is how we can write it. We can put any real numbers except 2. So I guess the domain is clear now. For the clarification, once again, whatever the number we can put inside a function logically is the domain of that function. For this one, anything is possible. So we get the domain as -infinity to +infinity, or real number. And for this one, we can also put any number and get all logical outputs. So again, real numbers are the domain. Here we can also put any number but not 2. Why? Because if we put 2, the denominator becomes 0 and we do not get any output. Okay, so we can write the domain as any real number except 2. We are going to discuss about another function. Let's say function number 4, where we have g of x equals to root over x. Now we have another function, root over x. We are going to input things, and remember, we need a logical output. That is mathematically correct. Now if I put g of a positive number, let's say 4, I do get an output. Root over 4 equals to 2. So obviously this 4 is part of the domain. Now if I put g of 0, I still get an output. Root over 0 is basically 0. But what if I put a negative number? Let's say I'm putting g of 2, -2. So root over -2, this does not give us any real output. We do not have any real output from this function for negative numbers, because root over cannot be applied to any negative number. So we cannot put any negative number in our function. So negative numbers are not part of our domain. We can put any positive number, we can put 0, but we cannot put negative number. So for this function, we can write d of g equals to all positive numbers. or we can write 0 to positive infinity. That means we can put 0 and all positive numbers, but we cannot put negative numbers. I guess from these examples, the idea of domain is clear. Now, let's move on to range and see what range actually is and is this related to domain or not. Let's go. Now, once again, we have three examples. Now, let's put values, domain, and see what our outputs are. Okay, for this one, again, let's put a positive number. So let's put 2. So what happens, this function works as it adds 5 with the number we input and gives us a result. So 2 plus 5 is going to give us 7. Okay, I'm just marking the 7, the output. Now let's say we put 0. What do we get from this function? We have 0 plus 5, we get 5. Okay, now let's put a 7, minus 7. Let's put minus 7. So we have minus 7 plus 5, minus 2. Okay, now look at these numbers. We know that 2, 0, minus 7, these are domain, right? Whatever we can put logically and get logical values, those are our domain. So for this one, we have a domain of real numbers. Now look at the output. Also in our output, we have a negative number. We can get 5, that means a positive number, also another positive number. If we put minus 5, let's say f is minus 5, you can also get minus 5 plus 5 as 0. So what is happening here is you are getting positive number, negative number, 0, all of them as outputs. That means the output of the function is also all real numbers. We can get all logical real numbers as outputs. No number can be should be excluded from here, right? Okay, now these outputs, whatever is the output from our function is part of a range. That means we can get negative infinity to positive infinity, any number. For putting different values here, we can getting different values. If you put negative infinity here, you're getting the result of negative infinity. That means any logical value is okay to put in there. We're going to get all numbers. We can get positive, negative, 0, any numbers as outputs. So all real numbers are also possible as outputs. Now all the positive, negative, 0, all the possible values of a function are called range. All the possible values of a function are part of a set. That set is called range. Now see, the set is of real numbers. That means range is expressed as R, and whatever the function we are denoting with f, we write it just like the domain R of f. That means range of the function. Again, once again, what is a range? Range is the set of all possible outputs of a function. In this function, all the real values are possible for this function's output. So we say that the range of the function is all the real numbers, just like the previous one. I hope it's clear. Again, once again, all logical inputs are called domain, and the set of all logical outputs are called the range. In this set, we can get any numbers. We can put any number in there, and we can also get any number from there. So the range of this function is also R. Now it will get a little clear with the other two examples. Let's go. So in our example number 2, we have a function which what the function does is it square roots the number we put in there. Now if I put g of 4, I'm going to get a result. So root over 4, which is 2. Now if I put g of 16, it's going to square root over 16 and is going to get a 4, right? Just like this one. If I put z of 0, you are getting an output 0, root over 0, which is 0. Now see, we cannot put in a negative, as we have already seen. We cannot put negative values, because if we put negative values, the result is not logical. So negative values are not part of the domain. And also, as we are not putting any negative values and root over does not give us any negative values, we are also not getting any negative numbers as output. Negative numbers cannot be result of this function. You can put anything in there, you cannot get a negative. So we can get 0, we can get positive values, but we just cannot get negative. Negative numbers are not part of the domain, and negative numbers are not a part of the set of the range, right? Okay, so what can be the range of this function? If I say a range of g, I can say all positive values, right? 0 to positive infinity. I can get 0, I can get all positive values depending on the inputs, but I cannot get negative. So negative numbers are not part of the range. Our range is 0 to infinity. Now let's move on to our third one and see the outcome. So here we have p of x, which squares on number. Okay, so if I put p of 3, what do I get? 3 squared, which is 9. Now let's put p of 0. What do I get? 0 squared, which is 0. If I put p of minus 5, what do I get? Minus 5 square, which is 25, because square removes any minus and we get a positive value. Now see the input there, we have a positive number, we have a 0, we can have a minus 5, and we are putting positive, negative, 0, everything in there. So domain is actually real number. For this domain, if I write domain of the function p is real number, because there is no number that will be illogical to put in there. I can logically put anything and I can get logical value, right? But look at the outputs. When I put positive, the output is positive. When I put 0, the output is 0. That means positive. So if I put minus 5, that is a negative number, I'm still getting a positive number as the output. So even if I put any negative number in there, the output is going to be positive. Why? Because the square removes any negative, right? So doesn't matter whatever input I have for this function, I can never get any negative from this function. I'm always going to get a positive number, right? So if I find the range of p, I cannot get a real number because negative numbers are excluded. For this function, I can only get 0 and all positive numbers. So my range is going to be 0 to positive infinity. So this is how it works. I guess it's clear now. All possible outcomes of a function are part of the range. And here we do not get negatives. So negative numbers are outside of the set of the range. Here we can get anything. We can put any number, you can get positive, negative, anything, but not negative, sorry. We can get only positive values from here, not negatives. So the range is also 0 to infinity here, because inside the root over you cannot put negative, and we cannot also get negative as outputs. Here we can put basically you can put any number and we can get any number as output. We have proved it already. We have negative number as output, we have 0 as the output, we have positive numbers as the output. So any possible number is possible from this function. So our range is R, and here our range is 0 to infinity. We cannot get negative. Also here we cannot get negative, so our range is from 0 to infinity. So the idea is basically whatever logical values we can put in a function are domain, part of the domain, and for range, whatever logical value we can get out of the function is part of the range of that function. Now for domain, we cannot put values that makes the input illogical, and for range, we cannot have values that makes mathematics illogical or mathematically is not logical. So that's our domain and that's our range. We are going to practice exam questions when you deal with the question paper questions. So I guess what function is and how function works and the theory of domain and range is pretty clear. In our next video, function part 2, we are going to solve something that is called composite function. Until then, this is it for today. If you like this video, you can subscribe my channel and like the video. See you in our next video. Thank you.